Hello, folks, and welcome to part 2 of today's lesson. And in part 1, we looked at some possible examples of information, as well as a working example, or I should say a working sample definition of information, in which we said it was data which has been organized, processed, presented in some way, with a number of question marks, because, again, a working definition is not a final definition. As part of that, we decided to define what is data. We said data are representations of stuff, being intentionally ambiguous. We made the point that for data to be classified as data, it should be recorded, simple, and then raw and organized, and seemingly random, which are some attributes which may be a little bit harder for us to grasp. So I used a few examples, including this one, that sample data, right? As sample data, here we have some data about coffee, and I can put this data in any order, and it still really captures the same stuff, right? Doesn't matter the order; it can be randomized, so it's recorded. It's simple. It is, by just the very nature of it itself, it's raw and unorganized and seemingly random. So now that we've started to better understand what data are, and we have a working definition of information, I want to ask about the following example. Here is a number. Looking at this is another exercise for in class, but since we're trying to do this lesson online, I'll sort of give you some of the possibilities as to what this may be. Looking at this string of numbers, one possibility is that, you know what? This data may represent Social Security number. Positions 1 through 9 look, maybe they're a Social Security number. And the last digit is somebody's pay scale code. So, this could be a representation of an employee in an organization, right? We've represented them by their Social Security number and their pay scale code. 7 means we pay them at an hourly rate of $10.11 per hour. Just making that up. But that's a possibility. We don't actually know. Possibility number 2 is that the first 3 digits are an area code, 235. Fair warning, I don't actually know if this is a phone number. It's just a possibility. I don't even know what area code 235 is, or if it is an area code. Last 7 digits after that are the standard phone number, 711-1317. That's a possibility. So this could be representative of an employee, could be representative of a phone number. So I guess I've also answered the question, you know what, this is probably data, but I don't want to say 100% for sure. But what this is capturing here, it's possible that this is Dr. Mike's new salary as a clinical associate professor. Probably not, though. Probably not. And possibility number 4 could be my student loan debt with interest. That one is seeming a lot more likely. A lot more likely. So, these possibilities are really possibilities based on the lens or the context that we're adapting, right? So with our first possibility, right, this might be an employee. That's really looking at this through the organizational lens, probably from the lens of somebody who's working at HR. Second one, this could be through the lens of the context of contacts in your phone, right? Within that context, this takes on a different meaning, this number. And within context 3 and 4, which are pretty specific to me, right, this number might represent some dollar amount, which is different than a phone number, which is different than a social security number with a pay scale code added on to the end of it. And to make sure that folks are still listening, I want to give you a hint that the answer to question 4, that is question 4 on the pop quiz I'm going to give you on Tuesday, is letter E. Right? Question 4, answer is letter E, all of the above. Just wanted to let you know that, make sure you're still paying attention. All right, so this I will take the veil of mystery off. I'm presenting this really as data, and that data should be captured, or I should say that this number was meant to represent potential data, but really data needs to have some sort of context with it. So what I mean by that, we just went through 4 possibilities of what this number could possibly mean through different contexts, right? That what that number, what that data represents, changes. When we return to our example data from lesson 1, right, we had the string of numbers, we process it, and aha, we have information of the average. But really, there's not a whole lot of meaning here, and really the only thing we can glean from this is the average number from this data. And I don't know about you, but that doesn't really seem like information to me. Now, if I add a sense of context, right, within a college class, this set of data, we're going to look at this and say, you know what, this probably represents grades that students got on a pop quiz. And it's quite possible that the person who got 46, the grade of 46, that was somebody who did not know that the answer to question 4 was E, all of the above. Right? And probably the person who got 60, maybe 72 didn't know that as well. But person number 100, or the person who scored a 100 clearly did. The larger point I'm trying to make here is that with a sense of context, right, these data are clearer, I should say, in terms of what stuff they're representing, right? These are representative, in this example, of student grades on a test. So what I can derive by doing some processing of that data is that the average grade of students on this quiz was 81.25, right? And as a professor, I'm going to look at that and say, you know what, that means my students really maybe skimmed over those PowerPoint slides I told them to review since they went to the football game, or something like that. I'm just making up examples now. This data may take on different meaning through a different lens, through a different context, right? Within the context of the stock market, these numbers may very well capture, represent the way that stocks closed for the day, right? So the average stock price we can derive from this data was $81.25, right? The context is necessary to understand what the data are capturing, and therefore the information that we're processing from that data. And if I add even more data, right, and if I add a second set of data to this, I can derive even more detailed and additional pieces of information. So in data set 1, I'm going to say that the context are representations of stocks at the opening of the day. Data set 2 is a representation of individual stocks at the end of the day. Again, still within the larger context of the stock market. And so, of course, I can still derive from that the average value of stocks now at open, the average value of stocks now at close, and I can do comparisons and derive information between these data sets. So that the average stock growth was 0.62%. That is a piece of a point of information that I can now derive from this data. And I can look at that first stock and say, you know what? The first stock overperformed. The average growth was 0.62%. But that first stock there almost doubled in price. In fact, it grew by $38. So, although these may actually have been pretty horrible examples, I show them because they're simple, fairly straightforward, something we can connect with, but to make the larger point that to derive information from data, we need a precise definition of the context. We need to understand the lens through which this data is recorded, is captured. That is the lens of what the data is meant to capture. So in other words, we need data that describe the properties of data to infer information from that data. And some of you may know this, some of you may not, but data that describe the properties of data is something that we popularly call metadata. Metadata are data that describe data, which means what exactly? Well, metadata is where we get the sense of context. So, or rather I should say metadata is how we capture that sense of context. Here is a screenshot from my MacBook Air. This is some metadata about a file, a PowerPoint file. The PowerPoint file we're looking at now, in fact. I'm magical that way. I was able to pull that up, take that screenshot as we're doing this lecture here. And this is data that is describing the data of that file, right? This is describing the kind of file it is, the size of the file, where the file is located, when the file was created, modified, folks who can access this file, when it was last opened, and there are additional points of metadata that I have not shown here in order to make sure everything fit onto the screen nicely. So that is an example of metadata. Here is another example of metadata. This is a photo that I took on April 11th, 2015 at my previous institution during an athletic event. So here, obviously, we see an image of somebody in a pool. And to the right of that are some metadata about that image that you're seeing there. Shows a number of views, where the image was taken, the device that was used to take the image. It also denotes the app that I used in order to take the image. There are some more technical points, such as the aperture and the shutter speed and the ISO, things that photography geeks like myself sort of look at and understand. This is metadata that is embedded in the file of the image. And when I uploaded the image to Flickr, it organized and presented this metadata in a nice way. So in some regards, we kind of look at this and some folks would say this is information. It's really metadata. Looking at this and processing it, and I can make some inferences from the way it's presented, and that's closer to information. Also, this is a great example of where the distinctions between information and data aren't quite so clear-cut. And here's the thing, I want us to be okay with that. Right? The point of today's learning materials is really to talk about, well, ultimately we're going to define what is an information system. The deeper conversation here is data versus information. But at this point, I'm comfortable telling you that sometimes a thing can be data, and other times information, and other times metadata. But it's really about the larger scope of how we look at these concepts, right? So here's another example of metadata called detail records. So this is an example of metadata of phone calls. Now, what I've captured in this table are representations of each call numerically. So every time a call is placed, it's assigned a new number. That's the call record. The owner, the phone number of the owner of the phone, the call number, that is the person, or I should say the number that the phone owner has either received a call from or has made a call to. We also show the call direction, the date of the call, the time, the longitude and latitude of where the call originated, and the duration of the call. Now, of note, the content of the call, that is, what the folks on the phone actually talked about, is missing, right? These are data about the phone calls, not the phone calls themselves, right? The term meta is stuff about the thing. And yes, that was very ambiguous, intentionally so, right? The term meta is often used as something that's describing the thing that we're focusing on, right? So this is data about a phone call. Previously, we saw data about an image, data about a PowerPoint file. This is the concept of metadata. In databases, right, there's data dictionaries and indexes and other sorts of tools where folks can define and look at the metadata of different fields in a database. And this is a concept we will return to later on in the semester. But this example that is shown here is for each row in a particular table. I'm defining the name of the column, the sort of data that's going to go in that column, whether or not any cells, any records in that column can include a blank, and a description. Right, I'm further describing what is in that, what that column is capturing, right? What that column is meant to capture. So the first one is capturing a unique employee number, right? The data type is an integer. It has to be a number, and it can't have a null, which means we have to put something in there. Every employee has to have a number. Now, these aren't the employee numbers themselves. The employee numbers themselves are meant to represent employees. The next column is employee first name. That's meant to capture everybody's first name, and then last name, and then their date of birth. And here we're simply describing that. We have an index, which is telling us the data about the data that this table will capture. And you are right to be confused. You are right to think this is making your head spin a little bit. But this is all part of the ambiguities and the messiness that we're going to be dealing with here. And we'll muddle through it. But it's important to be able to put some definitions on these terms so we can start to have conversations about these sorts of things. So back to information. We said information were data organized, processed, and or presented in some way. So the in some way bit, I'm going to go ahead and correct that now. Say it is presented within a meaningful context. And when we say meaningful context, we're really thinking about metadata, right? At least for the way I want us to conceptualize information as the product of an information system, presented within a meaningful context. Information tells us something about our world. What that something is, we'll get there. That something is meant to be intentionally ambiguous. That's what I meant by we'll get there. Information is not random. Data are random, right? And I showed that by random, I meant we can sort of put them in any sort of order and they're still representing what they're meant to represent. So information, on the other hand, is not random, but purposeful and intentional. Information is represented, interpreted, understood, and used by humans in our minds. And really, this is a point that I'm putting out there really as a seed. And when I say a seed, a point that maybe we don't understand yet, but we'll come to understand. To compare and to really give us the results of this battle between data and information so far, data, as a reminder, as a review, as a refresher, unprocessed, seemingly random. And I'm adding to this a little bit here now, as this segues into our next part of the lesson. Data are used by computers. Data are utilized by computers. And data are the building blocks of information. But data in and of itself is not information. Information, on the other hand, is organized, processed, and presented in some sort of context. Information is purposeful, not random, not unorganized, but purposeful, to capture something meaningfully. And when I say meaningfully, I mean to people. Information is used by people, not by machines. We call it information technology. Many folks use the terms data and information interchangeably. Understandably so. I do this. But when I'm teaching, when I'm trying to describe and reflect on and explain information systems, I try to keep these separate, which can be challenging sometimes. And as we said earlier, the lines blur, overlap. One person's data may be someone else's information based on the context. Even metadata is kind of messy in that sense, but we want to try to keep these as distinct as we can, particularly data information that is information is derived from data, from stuff that represents stuff, which is clearly not making things clear. And I do want to go a step further, and this is going to be in the next part of the lesson. I'm going to say that information is a building block, or comprises the blocks that lead to wisdom. As data leads to information, information leads to wisdom. What I mean by that, we'll come back to. Right. So one more time, now that we have defined data, information, and metadata, let's look at some examples again. Again, this works way better in a classroom of students. Is this data or information? What about this? Right? This probably information to someone, may not be information that has meaning to you. Probably, maybe, possibly, you have not learned the language that allows you to understand this information. Remember, we said information is understandable to humans. This was probably created from data, or I should say this was created from data, right? Representations of some sort of process of steps in ordering a pizza, representations of that. And those steps themselves may have been information to someone else. But whether or not this is information for you specifically could differ from person to person. But it has been organized and presented in some sort of meaningful context. We said earlier that this was data. Now you're questioning that. That's good. What about this? Is this information or data? And finally, for this part, before we go into the last part, is this data information both or neither? This is a graph showing the number of people who drowned by falling into a pool and its relationship to the number of films Nicolas Cage appeared in during a given year. And this shows that the number of people who drowned by falling into pools actually correlates with the films Nicolas Cage appeared in. On a sidebar, this is also a lesson that correlation does not equal causation. That is, just because Nicolas Cage and the number of people who drowned falling into pools seems to line up, that does not mean that one had a causal effect on the other one. So with that, thanks. Take another break and then tune in to part 3.